Good morning, students. In this video, we will discuss the steps in B+tree deletion. Okay. So whenever we are deleting the elements, we should worry about the underflow condition. Why we should worry about the underflow condition is that if you see the B+tree properties, if you have not gone through the B+tree properties video, I request you to go through that video and come back to this one for better understanding. So in a leaf node, we will say that any node will have p by 2 minus 1 is the minimum number of elements and maximum it can consist of p minus 1, where p is the order of the leaf node. Okay, so whenever we are deleting it, after we should not consist of less than p by 2 minus 1. Okay, so now let's take that. If the node consists of more than the minimum number of elements, then we can just delete it. Let's take that the minimum number of elements each node should consist of, let's take that it should consist of 3 elements. Okay, so 3 keys are there in the leaf node, and I have inserted another one, so it consists of more than the leaf node. Now someone has asked me to delete the element 1. Now the minimum number of elements are 3. Okay, it has more than the minimum number of elements, so I can delete 1. If I delete 1 from this one, the remaining elements are 2, 3, 4. So we have 3 elements. So it has minimum number of elements after deleting 1. So it is not an underflow condition. So I can delete the element without any problem. Okay. If after deleting, let's take that we have deleted 1 successfully. After that, someone has asked me to delete 3. If I delete 3, the number of elements are only 2, which is less than the minimum number of elements. Then what we have to do is that first we will try to borrow from the left sibling. If it is not possible, we will try to borrow from the right sibling. Okay, I hope everyone know what is a sibling. Anyway, for understanding, I will discuss what is a sibling. If you see this node, if you consider, let's take that I have 4 nodes A, B, C, D. If you take the node C has B and D are the left and right siblings respectively. So for C, left sibling is B, right sibling is D. Okay, so if C has less than minimum number of elements, so it will try to borrow from the B. If it is not possible, it will try to borrow from the D. That is the what I want to say from the point number 2. Now what is the point number 3 says? If step 1 and step 2 is not possible, then merge the node with left sibling or right sibling. Okay, we have to merge. Suppose we cannot able to borrow from the node B and we cannot able to borrow from the node D, then we will try to merge the C and B. Okay, if it is not possible, we'll merge the C and D. Okay, if merge occurred either with the B or with the D, then corresponding entry from the parent node should be deleted. What is the meaning of this one is, let's take this another example. I have 20 at the parent node and at the leaf nodes I have this one, because this is the property of B+tree, because all the elements, means if I have the elements 10 and 20, they will be there in the leaf node. Okay, in the leaf nodes all the elements will be present at the leaf nodes. Okay, that is what I want to say. So right now 10 and 20 are the key elements are there in the B+tree, so they are present in the leaf nodes. Then one index entry should be there in the non-leaf node. What is the property of B+tree? If 20 is there, the elements less than 20 should be there in the left subtree. The elements which are greater than or equal to should be there in the right subtree. So when we are merging, let's take it we are merging 10 and 20. If we consider this one also, it will be 10, 20, 20. This is a duplication. So whenever we are merging in the corresponding entry from the parent should be deleted. So we should delete this 20. Otherwise it will be a duplicate entry. Okay. Step 4 may propagate towards the root and decreases the height of the B+tree. Why so is that? Now I have deleted the N20, so I am removing an element from the parent node. Okay, then this node may go for the underflow condition. So then it will try to borrow from its left sibling, or it will try to borrow from the right sibling. If it is not possible, it will merge with the left sibling or right sibling by deleting the corresponding entry from the parent node. So it will try to delete the element from the parent node. So then there is a chance that the height of the B plus tree may reduce. Okay. Now all these steps comes to the all these steps, step number 2, step number 3, step number 4, step number 5 talks about the leaf nodes. Now the step number 6 will talk about the non-leaf node. If the deleted entry means whatever the key you want to delete is there in the non-leaf node or internal node or root node, then replace with in-order successor. Is it clear? I hope everyone know what is an in-order successor. In-order successor is from the right subtree, the minimum element should be replaced with the whatever the element you are deleting. Okay? Is it clear? So, in the next video, I will discuss a numerical examples in the deleting of the B plus tree so that you will understand all these steps in a better way. Okay? Thank you so much.